So this is my submission for Hda Ia 2. My topic is healthcare data analytics, and these are the publication details. So introducing my topic, one of the promises of the growing critical mass of clinical data accumulation in electronic health record systems is secondary use or reuse of the data for this other purposes, such as quality improvement and clinical research. The analysis of this data is usually called analytics or data analytics. We will define the terminology of this field, provide an overview of its promise, describe what work has been accomplished, and list the challenges and opportunities going forward. The terminologies. Analytics is the extensive use of data, statistical and quantitative analysis, explanatory and predictive models, and fact based management to drive decisions and actions. There are three levels of analytics: descriptive, predictive, and prescriptive. Descriptive is standard types of reporting that describe current situations and problems. Predictive is simulation and modeling techniques that identifies trends and portend outcomes of actions taken. Prescriptive is optimizing the clinical, financial, and other outcomes. A core methodology is data analytics is machine learning, and one of its major techniques is data mining and big data, which has the following attributes. So a core methodology in data analytics has the following attributes, which are volume, velocity, variety, and veracity. So volume is ever increasing amounts, then velocity is quickly generated, variety is many different types, and veracity is from trustable sources. The process of big data and analytics resembles a pipeline and has four major steps to which we can place data sources and actions on it pertinent to healthcare and biomedicine. The pipeline begins with input data sources, clinical records, financial records, genomics, and census data. The next step in feature extraction, which is to organize and extract elements of the data, such as linking records across sources using natural language processing to extract and normalize concepts and matching of other patterns. This is followed by statistical processing, where machine learning and related statistical inference techniques are used to make conclusions from the data. The final step is the output of predictions, often with probabilistic measures of confidence in the results. Now, this figure depicts what we just discussed in analytics pipelining. Now, let's move on to challenges to the data analytics. So, the data is generated in routine care of patients, which may be limited in its use for analytical purposes. For example, such data may be inaccurate or incomplete. Clinical data mostly allows only observational and not experimental studies, thus raising issues of cause and effect of the finding discoveries, and then ethical concerns over how the data of individuals is used, the means by which it is collected, and the possible divide between those who have access of data and those who don't. Now, research and application of analytics. We'll discuss about that. So, firstly, applying analytics to improve healthcare is in its early stages right now. And so, the research demonstrating how data from operational clinic systems can be used to identify critical situations or patients whose costs are outliners is emerging. There is a less research demonstrating how this data can be put to use to actually improve the clinical outcomes or reduce costs. Researchers have used EHR data to replicate the results of randomized controlled trials, which are called as RCTs. A number of critical clinical situations have been amenable to detection by analytics applied to EHR and other clinical data. For example, predicting 30-day risk of readmission and death among HIV infected patients, then identification of children with asthma, then risk adjusting hospital mortality rates, then detecting post operative complications, measuring processes of care, determining 5-year life expectancy, detecting potential delays in cancer diagnosis, identifying patients with cirrhosis at higher risk of readmission, predicting out of intensive care unit, that is ICU, cardiopulmonary arrest or death. Now these are the few examples of application. Using the Health Maintenance Organization research networks, virtual data warehouse, that is VDW project, researchers were able to demonstrate a link between childhood obesity and glycemia, in pregnancy, using United Kingdom's general practice research database to demonstrate the ability to replicate the findings of Women's Health Initiative and RCTs of other cardiovascular diseases. As the volume of clinical data and need for analytics continues to accelerate, systematic approaches will be required for sustained successes. Adherence to best practice for use of data standards and interoperability, then processes to evaluate availability, completeness, quality, and transformability of data, toolkits and pipelines to manage data and its attributes, challenges and metrics to assessing research grade of operational data, standardized reporting methods for operational data and its attributes, adaptation of best evidence approaches to use operational data. So these are some of the key points. Healthcare data has proliferated greatly, in large part due to the accelerated adoption of EHRs. Analytics analytic platforms will examine data from multiple sources, such as clinical records, genomic data, financial systems, and administrative systems. And there are a few other key points which you can see. In conclusion, clearly there is a great promise ahead for healthcare driven by data analytics. The growth quantity of clinical and research data, along with methods to analyze and put it to use, can lead to improvisation in personal health, healthcare delivery, and biomedical research. However, there is also a continued need to improve the completeness and quality of data, as well as conduct research to demonstrate how to best apply it to solve real life problems. In addition, human expertise, including informatics, will be required to optimally carry out such work. Thank you.